Thank you. So we thought we'd take a slightly different look at, I think some of the things that I was quite impressed that some of the speakers have spoken about is taking an integrated look at how do we look at both sides of the equation, and that's probably where we're going to concentrate. There are four key things I wanted to touch on. One is combining load and supply management, using smart analytics to optimize the mining load, which could be for any load, but we have tried to concentrate more on mining because it can vary whether you are in a beneficiation process or you're actually just in the core mining process of just digging and shipping out. Then I wanted to look at the integration of renewables as to what they mean in terms of when you're on the grid or you're off the grid, and how does that impact on your load supply. And the fourth one was to look at secure remote operations and how that can come into picture in the overall scheme of things. So I want to just start by giving you a bit of an introduction to Honeywell. Honeywell is an international company with about $40 billion of revenue, and it's a Fortune 100 company. We are in most countries that you visit. And a couple of things I just wanted to mention about our aerospace division. So if you have ever flown in an aircraft, chances are that the aircraft was flown on a Honeywell system. And the other thing is, if you have been bothered by the internet connection, you can probably blame Honeywell for it, because we're the ones who are bringing Wi-Fi to the aircrafts. So we have been looking at asset optimization quite a lot, and that takes care of the both sides of the equation, which is the theme of I quickly want to get into. In Australia, we have about 2,000 employees, but that is across all our divisions. That's not just in the renewables division. And we are about 300 odd people that look into the industrial automation projects. Okay, that's enough about Honeywell. I wanted to start with this statement from Dr. Alan Finkel that struck a chord with me, which said, engineering is the art of optimization of key outcomes or objectives. Now, the key here is that we are trying to optimize the objectives. We're not trying to find a compromise between them. And that I thought was very powerful. And this is what it goes into. And I'm sure you would have seen this duck curve issue that had come up in California, and very recently we are starting to see that in South Australia, which has been under quite a bit of pressure. The grid is under tremendous pressure because of all the renewables that have been added. And it is not going to get better. It's only going to get worse as we bring in more renewables, which are really loads that you cannot predict. The generation that you cannot predict. And especially when you go into solar PV, you look at the curve that, if I might point you to around 5 p.m. or thereabouts, there's a very steep curve. Now, somebody has to fill that curve in. Either you go back to your normal generators, create your spinning reserve, or there are other options, which we discuss a little bit later. But I thought I'll just raise that, what we are getting into. So this is from looking at it from a grid perspective. But if you're going to go onto your own grid, and you introduce in a microgrid your own renewables, this is what we are in for. And knowing the problem is the first problem to acknowledge it, the first step to acknowledge it, so that we can actually go and do something about it. Now, the two sides that we wanted to look at is the supply side optimization and the demand side optimization. And if you look at carefully, we're trying to do a nice balance between the two. So one of the things you look at is always source prioritization. If you have a solar PV or if you have wind generation, you want to maximize it because it is virtually free. And that starts to now impinge onto your supply quality, which basically now and you can take care of if you have supply quality issues, this is an excellent opportunity to actually look at that and use your inverters to actually look after the supply quality and create a spinning reserve. Now, we talk a little bit more about spinning reserve. There are many ways of doing it, but I think batteries are coming, and that's what I want to talk about a bit later. But the beauty of it is, when you're looking into your equipment load, this is a great time to look at optimization. Optimization on an equipment level, optimization on a plant level, and do the load management now because your generation profile has changed. You want to make sure your load profile. And I was very pleased to see Sun Metals, their approach, how they've actually gone about actually changing their load profile, the operation of the plant. Now, not everyone has that ability, but I'm sure there are opportunities within every operation where you can go and say, I don't need to run that particular pump, or there are sacrificial loads, or there are discretionary loads that I can actually bring on or take off as I need to. And again, if you have batteries, brilliant. Even without the batteries, it's quite easy. So what has happened in the past is, historically, we've looked at only two things, power quality and peak shaving. We're getting into now more sophisticated algorithms, and this is where, we pride itself that Honeywell has come out with algorithms which are, standard algorithms, but more advanced, that can stack multiple of these benefits. And we can look into, overall energy management. We can go into, capacity firming, and that's all been possible because you're able to actually bring multiple stack of these. And I'm not saying that all 6 or all of these can be applicable or can be achieved, but there's multiple of them that can be achieved for any given plant. So how do we do that? And I was talking about the batteries, and I'm a big believer in the batteries. Batteries are coming, batteries are here, and they're going to be probably the biggest thing that we will see. The beauty of batteries is that it is a load as well as a generator. Now, going back to the curve, the duct curve that we were looking at, if we were to fill that with anything that's quick ramp up, you got very limited choices, and you need some sort of storage. We've gone down the path of looking at batteries. Of course, you can have hydrogen storage. Of course, you can have hydro storage. But the kind of quick response that batteries provide is probably unmatched. And how do we do it? So this is one of the proprietary things we do, which is an energy arbitrator. We've taken the cue from the equalizers, and those of you who may be old enough to remember the equalizers in our stereo systems. This is where it comes from. The concept comes from there. And you are able to predefine what limits you want to work within. And within those limits, the arbitrator can actually automatically set those limits or change those parameters, or you can manually go and shift what is more important to you at this point of time. Can you tolerate more frequency at this stage, or is the power quality more important? Is the power factor more important to you at this point of time? And all those things you can actually, if you know there's a big cloud cover coming, if you know that there is a big load coming on, then you can actually increase your spinning reserve. Those are all the kind of things that you can do as part of this, and this is all bringing it all together, looking at both sides of the equation, because a load increase is almost the same as loss in capacity, and a loss in capacity is the same as an increased load. So if you can predict those things, you're able to to look after them. The last point I make about is that in order to do that, you got to look at it, the whole thing, take a holistic view. You want a system that is able to integrate the whole part of it. Now, I'm not saying that Honeywell is the only company that can do it, but this would be my message to you, that look at the whole of the plant and reduce the weak links, which comes in the form of communication with third-party systems. And no matter how much we do, those systems, the moment we talk to a foreign system on a foreign protocol, that make sure that actually works and works for all the time and for under all the stresses that you're going to put it. Okay, I want to share a couple of case studies where we've done in the microgrid solutions. And the typical steps we take is we identify the system, we model it up, and then we go and do the data collection. So we will collect all the data from both the sides and then schedule an optimization, basically just go and implement whatever that optimization comes through. And we do it as an advanced process control, and that box basically then goes and optimizes. And you can choose to keep it, or you can just choose to implement the controls of your own. This is a real-life example from where we were able to optimize the energy purchase and sale, where after changing the energy consumption, and these decisions are not taken based on technical reasons. All these are economical reasons. You look at who is providing, where can you get the cheapest electricity, where you can, or any energy form for that matter. I mean, if you have integrated energy in the form of steam or fuel costs or in the form of heat, you can optimize any form by using that. So, what are we looking at in the form of, look, we have solar PV panels, which are coming, battery energy storage system that is here, and I think there's a great way to go for them in future. We need an automation system that can actually tie the whole thing together. You need an energy management system that can look after the whole of plant. The one thing we did not touch base on was actually SCADA in the cloud, and I think that's coming as well. Most of the remote mine sites, and I'm sure if there are any controls engineers here, you would probably resonate with me, that you don't want to keep much of hardware at site, which is non-industrialized hardware such as PCs, and the problems that we have in the Microsoft world that we live in keeping them updated all the time. We want to take that away as well. What we would suggest is, if you have a reasonable enough internet connection, do the SCADA in the cloud. That minimizes anything hardware that you keep on site, and this is all dumb terminals that you have, and let somebody else worry about keeping the hardware, software updated. And look, it's for a non-critical application. That's great, especially if you're running something like a solar PV plant, which does not require a lot of intervention. It's great. But if you get into real quick decision making, and if you're totally dependent on internet connection, I would caution that, have a look at it, that it is at least, at least you've got two ways of communication and thereabouts. And that comes in with the industrial security. You need or cyber security. You're gonna put your data on the cloud, and you don't know where that server is. You definitely want to make sure that cybersecurity is built in the solution that you have. So on that note, I just wanted to leave that with you, and that was pretty much the end of my presentation. Thank you very much. Thanks for listening.